Welcome to our presentation on Everitt Lab. We are Group 7 and today we will be discussing our term project focusing on insights and findings related to Everitt Lab. Here you can see the member of our group, Louise, Madison, David, Ben, Samin, and Carla, and together we've worked on this project in the best construction company. Everitt Laboratory is located on the North Engineering campus of the University of Illinois at Urbana-Champaign. Originally built in the mid-20th century, the building served as the primary facility for the Department of Electrical and Computer Engineering. In 2018, Everitt Lab underwent a comprehensive renovation to house the Department of Bioengineering, reflecting the university's growing emphasis on interdisciplinary research and innovation. The renovation, which cost approximately $55 million, transformed the 124,000 square foot building into a modern research and educational facility, integrating state-of-the-art laboratories, classrooms, and collaborative spaces. Everitt Lab serves over 1,200 students, including both undergraduate and graduate researchers. Everitt Laboratory is located on the University of Illinois' North Engineering campus, near key facilities such as the Granger Engineering Library and Engineering Hall. The building features 5 levels, including a ground floor, 3 operational floors with lab and office spaces, and a mechanical penthouse. A tunnel level connects the building to other parts of the campus, ensuring seamless access to utility services. The site provides critical infrastructure for research and teaching, particularly in bioengineering, and is equipped with high-tech labs, clean rooms, and collaborative spaces designed to support both student learning and advanced research. The primary purpose of the renovation is to modernize the building to better serve the Department of Bioengineering and the broader academic community. This includes upgrading the infrastructure to accommodate advanced research and teaching needs, ensuring the building meets contemporary safety and sustainability standards. The renovated Everitt Lab is designed to provide state-of-the-art lab spaces, classrooms, and collaborative areas, supporting cutting-edge research in bioengineering, biomedical science, and related fields. The renovation also aims to increase the building's capacity and functionality compared to its previous role as a facility for the Department of Electrical and Computer Engineering. The objectives of the Everitt Lab renovation focused on transforming the building to meet the needs of the Department of Bioengineering. The renovation aimed to modernize the infrastructure, including upgrades to mechanical, electrical, plumbing, and structural systems. A key goal was to create advanced labs with flexible design that support a wide range of research activities. Sustainability was also emphasized with energy-efficient lighting, improved insulation, and updated HVAC systems. The project focused on creating collaborative spaces for students and researchers and ensuring the building met modern safety standards, including ADA compliance. Additionally, updated classrooms with advanced technology were designed to enhance the learning experience for both undergraduate and graduate students. Overall, these improvements make Everitt Lab a modern, efficient, and safe space for research and education at UIUC.
After receiving our notice to proceed, it was important that we set up our site boundaries to ensure the safety of students and other pedestrians on campus. The green outline here shows the location of temporary fencing used to secure the project site. We're choosing a 6-foot chain link fence. Areas in blue are where existing concrete traffic barriers are already in place, so we're adding temporary fencing on top to ensure safety. There's an example of this in the photo on the slide. Access points with swinging gates are shown in red. The yellow indicates a sliding gate for vehicle access from Wright Street. The red swinging gate in the southeast corner is also wide enough for vehicle access if there are specific materials being delivered to the southeast corner of the site. You'll notice some interior areas of fencing in the southern portion of the site. These are for tree protection required by the university. We will be erecting 6-foot chain link fencing around all trees within the work zone to ensure minimal damage to their branch and root systems. Here you will see our different work zones within the project site. The blue indicates the active construction zones surrounding the existing building. The pink areas represent our temporary storage and staging areas, and we have space for our trailers and field offices within the southern staging area. Orange shows our loading and access areas. For signage, we will be placing safety and caution signage at every access point to ensure no unauthorized pedestrians enter the project site. We will also be placing informational posters at the northwest and southeast corners to provide students and faculty with project information and to get them excited for the new Everitt Laboratory. We'll maintain pedestrian walkways on the north, south, and east sides of the project site so pedestrians can safely travel around the perimeter of the site. On the west side, we'll be closing the sidewalk and posting signage to notify pedestrians to cross the street at that location.
To select the truck route, we started identifying the primary interstate highways near the Everitt Laboratory, and there are Interstate 57 to the west and Interstate 74 to the north. So from I-57, trucks will exit at Springfield Avenue, then turn left onto Duncan Road, and then right onto Bradley Avenue and continue straight. From I-74, trucks will exit onto Neal Street, then turn left onto Bradley Avenue. From Bradley Avenue, both routes follow the same path, so they continue east on Bradley Avenue until reaching Lincoln Avenue, where trucks will turn right, then turn right onto University Avenue, and finally left onto Wright Street, where the main vehicle access is located. We analyzed several alternative truck routes, and while some might be faster, they presented significant obstacles for truck circulation. First, we encountered a bridge with an 11-foot high limit making it impossible for typical mixer trucks. Second, the current road conditions on Springfield Avenue led us to reconsider this option. Finally, pedestrian congestion, lack of traffic lights, and narrow streets along this alternative route would pose an additional challenge, so we ultimately discarded these possibilities.
After mobilization, it is very important to identify all of the existing utility lines within the project scope. And to do so, site surveys and needs to be conducted, and a civil plan, as shown on the right, will be published in the design document. So I've marked up all of the existing utilities based on the civil plans, and everything has been colorized per University of Illinois facility standards, as shown on the right, on the screenshot on the right side. The existing utilities includes electrical lines, lighting lines, gas, steam, sanitary, storm, telecommunication lines, domestic water, and also chill water lines. All we're tapping into the building is additional steam from the steam tunnels, additional sanitary and storm lines, and additional domestic water line from the west of the building. Additionally, we're installing additional shut-off valves for the domestic water line. Even though there are quite a few different types of utilities on site, but we're only planning to disturb only a few of them. For example, to install those shut-off valves from the domestic water main, we need to coordinate with the Illinois American Water facility to for a shutdown in the local area. Additionally, we need to coordinate with the campus heating plant to coordinate a steam shutdown ahead of time. And Just in case, on the right side of the slide, you can see all of the facilities that we may need to contact with. And as always, call Julie before digging.
Determine equipment required for site clearance. We selected Caterpillar as the primary equipment brand due to the project's proximity to Caterpillar plant at Peoria. Additionally, we selected JLG as the telehandler brand because of its relationship with Caterpillar. For backhoe loader, we are using a 420F Caterpillar. For a skid steer loader, we're using a 226 D3 Caterpillar. We are using a telehandler JLG 1043 and one 16-yard dump truck. Existing site demolition. For phase 1, we are protecting all the historically significant areas that are marked in the plans. For phase 2, remove all the millwork and existing furniture. For phase 3, we are removing all the existing floor or carpets in the building. For phase 4, we are removing the bathroom fixtures. For phase 5, we are removing the suspended ceilings. For phase 6, we are removing all the non-bearing walls, in this case drywall boards and studs. For phase 7, we are removing indicated masonry walls. For phase 8, we are removing the indicated MEP materials. And lastly, for phase 9, we are using the chute to keep the area clean and all the debris managed. Since this is an existing building, it requires a lot of demolition, and to do so, we listed some of the equipment needed to do so. So we have the mini track loader. This is a Toro Idingo 500. It's located in the picture below, the one on the right side. Then we need a debris chute, a scissor lift. This is a JLG AE, a mounted dump. This is also a Toro Ultra Buggy. It's also shown in the picture right next to the mini track loader. We need a demolition robot, a telehandler JLG, and a 20 cubic yard roll-off dumpster that will be located on the west side of the building, right on the street. We also planned the entrance of the equipment into the building, and we plan to do it right into the west windows. We checked the dimensions of the windows, and they are around 6 feet width and 8 feet height, and all the equipment that we are using or planning to use has smaller dimensions, so we are okay with it. Since we are working in multiple floors, we need to lift the small equipments from floor to floor. But before doing that, we need to first check the windows and machine dimensions on site, keep the area clear in case of a machine failure or if anything of the equipment lifted slips and falls into the floor. Then do the actual lifting of the small equipment. We'll be working on the west side of the building and enter into the windows marked in the blue square, and repeat these steps for the next floors.
For the required equipment for excavation, we chose a backhoe loader 420F from Caterpillar, a skid steer loader 226 D3 also from Caterpillar, a CS5 compactor from CAT, and lastly a 16 cubic yard dump truck. There will be 4 cycles to move approximately 45 bank cubic yards or 54 loose cubic yards, assuming 20% of swell. Our phasing plan for excavation will begin with phase 1. Site survey and identify where the site utilities are located. Phase 2. Marking, filling, and cut locations are on site. Phase 3. Remove monuments and store them off-site. Phase 4. Remove indicated trees from construction site. Phase 5. Remove light poles, walkway ramps, stepping landscape stones, and handrails. Phase 6. Remove existing insulated steam line and stormwater drainage. Phase 7. Remove stone wall and earth behind it. Excavate to reach required level and transport the extractor material to a designated landfill. And lastly, Phase 8.
Bring in CA6 fill material and unload it on a designated space inside. Spread it with the backhoe and use a compactor to reach the wanted density.
There's a few other items that we need to do before start excavation. So per field verification, there's a creek north of the building, and just looking at the retaining wall of the creek doesn't seem like it was really structurally sound. So the very first thing we need to do is to document the existing condition, make sure the geotech membrane on the retaining wall is structurally sound. If not, we need to track the replacement quantity and get that submitted as an RFI as soon as possible. And the university would then decide if they want us to replace it or not. Another thing to look at before any utility work is always shutdowns, tie-ins, and then additionally there's any safety paperwork like hot work permit, life safety plans. We need to get them submitted probably a week or two ahead of time before we start working on utility work. Additionally, we need to set up straws around the site to prevent dust runoff, and also to prevent all the construction debris and waste from going into the creek north of the building. And there's a lot of existing vegetations on site, especially on the south side of the building where we're setting up our trailer. So we need to protect those trees before we start rolling with all this excavation equipment. And finally, we need to set up all the set up some gravel roads for our equipment to go on, just so we don't have to ruin a lot of the existing pavement or existing landscaping.
For excavation demobilization, first we will determine which equipment will no longer be required. Then, we will coordinate equipment transport with the owner of the equipment if it is a rental, or send it back to the storage unit of the company. After, we will determine if we need a flatbed rollback truck or a low-boy trailer for the equipment mobilization. Then, load the equipment to the truck and follow the truck route used before to transport it off-site. And regarding demolition equipment, follow the points stated above, but coordinate the extraction of the equipment from inside the building.
Because this is a renovation project, we not only need to look at all the new work that we're putting in, but we also need to verify all of the existing footings and foundations. Per field verification, there's the continuous wall footings that is holding up the exterior masonry wall, and this entire building has a pile system. It's a dip foundation system which go down probably about 20-30 feet um, underground, and then other than that, majority of the basement has a mat footing, and which most of them is about 5-inch slab on grade. And on the exterior side, there's some concrete paving, and then there's a little bit of foundation wall. So for the new work, we need to reinforce about 14 of the pile caps. Essentially, we're pouring this 4 feet thick concrete mat foundation on top of the existing concrete piles. And in additional to that, we need to verify if the existing piles are structurally sound. If not, we need to submit that as an RFI and confirm with the university and see if they want it replaced or not. And um, after that is done, there's the slab on grade that we need to pour just to replace the existing slab on grade on top of those new pile caps. And then on the north side there's a trench for the electrical work, and then on the south side there's a trench for the sanitary work, and that basically is all the new work for the foundation scope. Because this building is a renovation project, we need to get to the existing pile foundation to verify its structural integrity. Just to get to the piles, we need to demolish the existing slab on grade and some of the existing pile caps. just so we can replace the pile caps. So to do so, we're using instead of using a demolition robot, we're using power tools like cut-off saws and hammer jacks to demolish the concrete. And additionally, for the trenches, we're planning to use a Caterpillar mini excavator um, for excavation. The reason why we selected this model of excavator is because it is based on the manufacturer's specification, its boom height and its shipping width and shipping length will be small enough for our openings on the west side of the building. Additionally, we're also planning to uh, rent a few mini pile driver machines in case there are any existing piles that will need to be replaced. Um, just something that maybe unexpectedly come up, then we'll be ready for it. Based on a quick takeoff of the foundation plan, we estimated that we would need approximately 300 cubic yard of concrete for this entire project, just for the foundation. So assuming it's about 8 yards per mixer truck, we would need approximately 38 mixer truck and 1 pumper truck. Um, and another assumption is that a good concrete crew will be able to place 100 cubic yard of concrete per day. Additional details um, on the facing plan will be on the next slide. Again, based on the estimate, I was able to uh, break down this entire scope into 3 days of pouring concrete. So the first day would be um, in the blue area, which is the furthest away from the basement access, which is clouded on the left side of the screen. And then the second day would be the pink area, and the third day would be everything in red. So the pumper truck will be staged on the west side of the building, right outside of the basement access. And then on the mixer truck will be entering the site from the South Right Street entrance, which is on the west side of the building. And then additional staging area would be on the north side of the building, north of the creek. And the mixer trucks will be arriving in 45 minutes in intervals and then and stage on the west side of the building. And then with this 3 pours, we're only expecting the third pour to be that would require overtime. So see picture on the right for additional details. So just a quick summary of the foundation phasing plan. Step 1, we're going to demolish some of the existing slab on grade just to get access to all these existing piles and the pile caps. Phase 2, we need to verify and document all the existing condition and then have a geotech consultant to verify the ones that needs to be worked on. Phase 3, that's when we're going to start excavation and then pile reinforcement, starting from northeast of the building and then moving across the board, moving towards the west where the basement access is for the clouded area. And then the last phase, which is going to be pouring concrete. Based on this figure on the right side, we'll be pouring the slabs with the pile caps together based on this figure.
Phase 4 of foundations includes foundation demobilization. This will include removal of all power tools, excavators, and pile drivers from the work area. We will determine which power tools might be needed for future phases, and these will be moved to the staging area. Anything that will no longer be needed for future phases will be returned to the rental company or returned to our company storage if it is owned by the company. We'll then clear the ground floor of all debris, trash, and excess materials to prepare for the superstructure phases.
Our superstructure consists of both steel and concrete elements. We selected equipment specifically suited to each material, aiming for efficiency and safety in installation. In the following slides, I'll outline the key phases for steel and concrete work, the equipment involved, and our approach to phasing. We'll start by using a mobile crane stationed on the north side to efficiently lift and place steel beams. Steel is stored in the northeast staging area where it's protected from moisture, minimizing any risk of damage. Inside the building, a skid steer helps position beams precisely, while a beam lift crank sets each beam to its required height. Once each beam is in position, we apply temporary shoring to ensure stability. We then align beams with temporary connections, finishing with full connections to secure them. Our approach includes 4 steel deliveries, each timed with a floor level. This timing reduces congestion on site.
Concrete facing plan. So we decided as a group to use cast in place concrete. We're going to subcontract a company to do so. And as a pouring method, we are using a concrete pump truck. Regarding the concrete requirements, we did a rough quantity takeoff based on the structural drawings, and we estimated 405 cubic yards of concrete. That being said, that's around 50 mixer trucks, and we are assuming around 8 yards mixer trucks for each one of them. We are also doing assumptions for the crew. We are assuming 90 cubic yards per day. That's our target. And we are doing one truck unloading at a time due to space constraints. To do so, we need equipment and staging. So we are planning to use a pumper truck. This will be located and positioned on the west side of the building near the transportation platform. And we are also using concrete mixers, 8 cubic yard concrete mixers, and this will be staged on the street with rotation schedules to accomplish our goal.
After installing both steel and concrete, we'll begin the demobilization process. This includes removing the crane, concrete pump, temporary shoring, and restoring the staging areas. Once final inspections are complete, the site will be ready for the next phase, exterior cladding.